In November 2026, Voyager 1 will achieve a remarkable milestone. It will be 25.9 billion kilometers from Earth, exactly one light day away. At that distance, signals from the probe now take 24 hours to reach us. Each transmission from Voyager 1, now drifting through the interstellar medium, is a scientific treasure. Launched in 1977, Voyager 1 has completed an extraordinary journey, offering humanity its first true glimpse into the far reaches of our solar system. Along the way, it provided close-up views of the gas giants, discovered previously unknown moons, measured powerful magnetic fields, and ultimately crossed into the vast unknown of interstellar space. While a beam of light covers that immense distance in just a day, it took Voyager 1 nearly 5 decades to get there. Yet, no one sees this long journey as a drawback because the knowledge gained from this historic mission is still unmatched. Many newer probes have traveled faster and sent back higher resolution images, but Voyager 1 and its twin Voyager 2 were true trailblazers. Despite their age, they continue to break records and deliver groundbreaking data. Since passing the helipause in 2012, the boundary where the solar wind meets interstellar space, Voyager 1 has been transmitting information from a region no other spacecraft has ever entered. It remains a beacon of discovery, still pushing the boundaries of human exploration. At the edge of our solar system, the probe is capturing groundbreaking data, measuring particle densities, magnetic fields, and cosmic radiation in unprecedented detail. This information, revealing the transition zone between the solar system and interstellar space, ranks among the most significant scientific achievements of the century. As Voyager 1 continues its journey, every additional kilometer weakens its signal, making communication increasingly challenging. Its transmission power is now weaker than that of a household television. Yet NASA engineers persist in their efforts to keep both Voyager 1 and its sibling Voyager 2 operational. The monumental anniversary of these historic space missions is a perfect moment to revisit their most remarkable discoveries. One of the most astonishing came in March 1979 when Voyager 1 became the first spacecraft to fly past Jupiter's moon Io. The images it returned stunned the scientific world. They revealed massive volcanic eruptions, making Io the first celestial body beyond Earth where active volcanism was observed. Until that point, scientists believed geological activity occurred only on Earth. What Voyager unveiled was nothing short of extraordinary enormous geysers blasting sulfur vapor more than 300 kilometers into space. This dramatic phenomenon is believed to be driven by tidal friction, an effect caused by Jupiter's immense gravitational pull. The gas giant stretches and compresses Io, generating internal friction that heats the moon's core, triggering volcanic activity. Io's surface is constantly reshaped by this activity, covered in a vivid spectrum of sulfur compounds. Since then, many more dynamic, geologically active moons have been discovered, especially among the moons orbiting Jupiter and Saturn. The stunning beauty of Saturn's rings has fascinated astronomers since medieval times. But it wasn't until the early 1980s, when NASA's Voyager 1 and 2 spacecraft flew past the planet, that their true complexity was revealed. What once appeared to be a smooth 3-part ring system turned out to be composed of thousands of delicate individual bands, intricate structures made of ice, dust, and rock. Voyager's close-up images uncovered an astonishing level of detail. Chaotic yet mesmerizing formations stretching an immense 282,000 kilometers wide, yet often only a few meters thick. The rings seemed almost alive in their movement, while Saturn itself appeared calm and majestic. Within the rings, scientists found mysterious gaps, waves, and constantly shifting patterns. Of special interest were the so-called shepherd moons, tiny moons whose gravitational pull helps maintain the shape of the rings or even creates gaps within them. One such moon, Pan, was found clearing a path through the Enki gap like a cosmic vacuum cleaner. These groundbreaking discoveries sparked new theories about the origin of Saturn's rings and offered insight into the evolution of planetary systems. Some scientists believe Saturn's rings may resemble the early disks of material that once surrounded young stars, offering a miniature model of how planets are born. Voyager's legendary images were later surpassed by the Cassini space probe, which spent over a decade studying Saturn up close. More recently, the James Webb Space Telescope added another layer of depth with its stunning filtered images, continuing to unveil the timeless mystery and elegance of Saturn's rings. Jupiter's Great Red Spot was another major highlight. When Voyager 1 arrived at Jupiter, one feature quickly stole the spotlight: the Great Red Spot. Although this massive storm had been known for centuries, it had never been seen in such incredible detail until Voyager sent back high-resolution images. For the first time, we could clearly observe this colossal hurricane system, which is larger than Earth and has been raging for more than 300 years. Voyager revealed that the Great Red Spot is made up of swirling bands of clouds, crackling lightning, and fierce winds that reach speeds of over 600 km per hour. The storm's striking colors are believed to result from chemical reactions in Jupiter's atmosphere, triggered by sunlight and the interaction of gases like ammonia, hydrogen, and methane. One of the most fascinating discoveries was the presence of smaller storms and turbulent systems surrounding the spot. Some of these were seen merging with or being absorbed by the Great Red Spot itself. Over the years, scientists have tracked the storm's evolution, noting that its size and shape are constantly shifting. Occasionally, smaller baby spots have appeared mini-storms that may eventually join the larger vortex. Recent studies even suggest that the Great Red Spot might fade away entirely within the next few centuries. Coming up next, Neptune, home to the most extreme storms in the entire solar system. If you think Jupiter's winds are intense, wait until you hear about Neptune storms. When Voyager 2 flew past Neptune in 1989, our only close encounter with the distant ice giant, it revealed something extraordinary: a massive storm system called the Great Dark Spot. This swirling vortex, similar to Jupiter's Great Red Spot, was deep blue, ominous, and even more enigmatic. The Great Dark Spot is one of the most violent weather events ever observed in the solar system. Spanning around 13,000 kilometers, nearly the size of Earth, it unleashes wind speeds of up to 2,100 kilometers per hour, making Neptune home to the fastest winds ever recorded. Neptune is mostly made up of hydrogen and helium with a hint of methane. That methane absorbs red light, giving Neptune its signature deep blue color. Then there's Uranus, arguably the strangest planet in the solar system. Thanks to Voyager 2, we discovered that Uranus isn't just tilted, it's practically rolling through space. Its magnetic field is drastically misaligned, tilted 60 degrees from its axis of rotation, and even the planet's core appears to be off-center. As a result, Uranus tumbles through space like a lopsided wheel. Voyager 2 detected sudden magnetic fluctuations, unusual radiation belts, and strange magnetic bubbles. It was as if the planet were stumbling through space with each spin. Despite all its oddities, Uranus has remained stable for billions of years, and it's likely to continue spinning its weird way through space for ages to come. Scientists believe this strange phenomenon may be the result of unusual internal layers within the planet. It's possible that electrically conductive liquids such as water or ammonia are interacting with the planet's magnetic field, causing these unexpected anomalies. The pale blue dot. Today, both scientists and space enthusiasts consider this one of the most profound images ever taken of humanity. On February 14, 1990, as Voyager 1 drifted over 6 billion kilometers away from Earth, it received a final command. At the request of astronomer Carl Sagan, the spacecraft turned its camera back toward the direction it had come and took one last snapshot. That image became iconic, known as the pale blue dot. In it, Earth appears as a tiny faint speck just 0.12 pixels in size, floating within a sunbeam, almost invisible in the vast darkness of space. Carl Sagan would later reflect on the photo with powerful words: "That's home. That's us. Everyone you love, everyone you ever knew lived out their lives on that tiny mote of dust." This image isn't significant for its technical quality, it's important because of what it represents. It's a humbling reminder of our vulnerability and of the responsibility we share to protect this fragile world we call home. And then the alien signal in interstellar space. Since Voyager 1 crossed the edge of our solar system, the helipause, back in 2012, it has been journeying through the vast emptiness of